Check this out. Finally, good retracting wheels. Foot operated, quick, work intuitively like a pen, and satisfying, where I'm not alone. Whoa. How do they work? I'll show you, since they are part of this vice pedestal I built, my first real metal fabrication project for this big old vice that I restored and upgraded last time, but didn't have a place for it yet. No.
Ideally, it would be freestanding for best access, movable for flexibility, and height adjustable, since I'm not the only one using it. Take a close look at my colleague Robin. Yep, he's taller than me.
I'm taller than you.
So, throwing all this into the mix, I started with some rough idea sketches and took some real-world information like what's a comfortable height, where are my feet, and how big can the base be, what material is available. And for a better sense of scale and proportions, I 3D scanned the vice with my phone, but when Stefan saw the result, he just... and got out one of his toys, and yeah, that's better. And now that's the design I came up with. 3 legs with wheels, so it's never rocking, and an extending center column with handwheel for a height adjustment.
And to not get lost in complexity, I split the design into 4 components.
The column, the adjustment screw, the legs, and the wheels. The material just rolled in, and I'm gonna start with the column.
I'm going to build it from this 100mm square tube, 5mm thick and 5mm steel plate, which I'm going to weld into another tube where this can slide in. And to cut and weld those parts, now that I'm in a bigger workshop, I could get my hands on a laser welder and cutter. What does it mean? Well, this.
So we are now cutting through this 5mm thick steel plate, just like that. I've only got one word.
Amazing. And there are my parts. So this is the X-Tool Metal Fab, a laser welding, cutting and cleaning system that X-Tool gave me to use in projects and show you the good and bad. You know it, that's how the creator marketing works. And cutting this 5mm plate was half its capacity. We'll get to the 10mm plate later, but for now, this is the cut quality. Not bad. There is dross on most parts, which I need to knock off with the angle grinder. But then it gets closer to the stock plate quality that was cut on a laser with at least 10 times the cost of this one. The dimensions are good and consistent, and it was fast. The cutting time of these 4 plates was about 2.5 minutes.
The idea now is to wrap the box section with the plates like this and weld those 4 spots. But there needs to be some clearance for the tube to actually slide and not bind. So I placed some knife plates as shims on 2 sides that are 0.5mm thick and very lightly clamped the plates around the tube. Then a bunch of aligning with a hammer to ensure all gaps are closed. By the way, this tube building idea is inspired from Dirk Schmidt and his belt grinder build.
Alright, it's ready for tacking, so setting up the laser for welding.
The welding gun comes out of the CNC cutter, swapping the cutting nozzle with the welding nozzle, installing the wire feet, and switch from oxygen to argon as shielding gas.
On the machine, I select carbon steel, my material thickness, and my wire diameter, enable the feeder and laser, and off we go.
There are the first 2 tacks, and I flipped around for the next 2 for even heat input. Then the same for the other side, and a few more evenly spaced tacks along the length. And although tiny, those little welds are strong, which I'll show you later.
Alright, tacked together, I can take the clamps off and then hopefully slide it off again, probably hammer it. That's not moving a lot.
That was a lot of hammering, and the sweat didn't wait long. Let's fast forward through this 1 hour long work.
This shim is almost free as well as this one, and that's poking out too. Hopefully it gets a lot easier once those two are out. Yeah, they're definitely out now. And this one as well. Almost. Oh yeah, it's a lot more progress per hit now. Yeah. Good. There we go. Now, will it slide on easily, and was 0.5 millimeter of a gap enough? Yes. It was worth it. That's beautiful. It's actually very smooth and just a little bit of play.
That means now welding it out solid, but again in short stitches and rotating to keep the heat input even and prevent warping. By the way, welding with the laser really is as simple as it looks like. For these weld seams, I'm just standing there and pulling the trigger. That consistent feeding looks like a skill, but that happens automatically through the wire feed. I just ground a tiny chamfer before assembly to guide the wire with. The machine does the rest.
And look at those super narrow heat affected zones. That's great. Now cool down, you can see there is a skill involved. This bead dishes in a little bit, and this one looking much better, more like a typical weld bead you would expect. That's directly influenced by the welding gun angle. Here I was holding it pretty steep, which means more concentrated heat on a small area, thus the dishing. Here I adjusted to a shallower angle, getting a much better result. But are those tiny welds even strong? Well, looking inside the tube during the welding, you can see sparks coming out. And inside, you can now see the root. So this is a full penetration weld, which means the entire material thickness got melted together, making this a single piece now, and more or less the same strength as this tube. So, yeah. That's strong enough.
But I wanted more proof, so I made some samples, cut them in half and etched them to reveal the weld. All this different looking metal is the weld seam, and it truly went through the entire thickness. Unfortunately, through that additional heat, the tube shrunk by about 0.3 of a millimeter, causing some binding. So I blued all the contact surfaces and ground some material away for the necessary clearance. And with a good fit again, I cut it to length. Then there needed to be a slot cutout that I started with a hole and finished with the laser in its handheld cutting mode.
Alright, those are the column tubes so far, and next come the 10mm plates that go on top and bottom. And that one is much heavier.
Back in with the laser gun and start. Let's see if it can do it. That was a yes. This camera angle is amazing to watch, but we're still dealing with molten metal here, where I got a reminder right here. Poor little camera, but just a protection. I'm only 30% stupid. You can also see that I did a few test cuts near the edge to find parameters that produce good results, but again, fascinating. 10mm steel, more or less out of the box.
Alright.
Most holes are free or just need a little tap, but the parts themselves won't release just yet. Let's have a look.
Wow, a significant amount of draws this time. Probably my parameters are not the best yet, and we're at the limit of the laser. It comes off relatively easy though, so let's get them free.
The remaining dross breaks off pretty easy, leaving only a tiny burr to grind off.
Very impressive.
I'm new to this stuff, so if you have experience and ideas to improve the cut quality, please let me know. What I've now is definitely a usable result coming from little effort. A bit more machining was necessary, so the outer holes got M10 threads and the inner holes got opened up to a M6 through hole and counterboards to fit a socket head bolt.
So that's the top and bottom plate. The welding comes later, because with the parts separate, the assembly of the other parts will be much simpler, especially the height adjustment mechanism, which I'll be making next.
It will be made from a trapezoidal screw and nut, some bevel gears, a hand wheel, and a few other parts. Everything is round, so onto the lathe.
By the way, the backbone of the little 3D animations, and well, the entire design, is a good CAD model, for which I'm using Onshape, who sponsored part of this video, but also Just Deliver.
Being cloud-based gives you the freedom of working from anywhere and removes the need of installation, updates, and a powerful workstation altogether.
Try it for yourself, get up to 6 months for free with my link in the description, and while you're thinking what you can make with it, let's continue with the spindle.
The end of the screw got turned down to fit the bevel gear. Then a precise 10mm section and M8 threads for the end.
It will be mounted to the top plate, and then as you crank and spin it, this will push the column apart and raise the vise. So there needs to be some kind of an axial bearing to keep the friction low, and it needs to be good at handling impact loads, because this being a vise, there will be hammering.
So I designed a simple bearing that uses a bronze washer and includes some mounting holes. All parts are simple and fit on a single drawing, so let's start with the upper, sort of, bearing race. First, after turning the OD, came a through hole for the spindle, then the bore for the bronze washer. And then the 6 threaded holes that I could drill and chamfer with my 2-post milling spindle, but the threads I did on the drill press after cutting it off, because they're simpler and much faster. Next part is sort of the lower bearing race, which has one diameter fitting the bronze washer and a reamed hole that, after cutting the piece free, fits on the spindle. Now the bronze. Very simple, just the right OD to fit the first part and a right size ID to fit the second part. It's just 3mm thick, and then the vise had its first good use pressing the parts together.
Now the parts go together like this. First the bevel gear, then the bearing, later with grease, held together by this very simple part I don't need to show making, and a nut, later lock nut. There we go. So next comes the hand wheel assembly, where the second bevel gear mounts.
A small assembly built from tubing, plate, more bushings, and a shaft. The tube is just off-the-shelf material, and the disc I could laser cut from 8mm plate. I just didn't nail the fit, but that's something a hole saw can fix quickly. Nice. Then I put it in the chuck with a specific stick out and took the chuck to the welding table, where I had my first actual use of the removable sled. Clamping the disc against the chuck jaws ensures it to be perpendicular to the tubing for welding. The wall thickness is 3mm, so that's the setting I went with. At first 3 tacks, and then all around.
The result, I would say, is okay. It's definitely welded together, but there is some practice with the feed speed of the gun plus the circular motion. So, like other welding skills, practice.
Back at the lathe, I cleaned up the edge, faced it to length, and turned the ID for the bushing press fit to just under 22mm. With the milling spindle, I drilled the 3 mounting holes, and lastly, on this side, cleaned the OD for remounting the other way. There I cut off the excess tubing and prepared the same bushing press fit. So far so good. Now the bushings, which just need 22mm. Wonderful. For the installation, I heated the tubing to expand it, and the bushings can just drop in. At least, that's the theory, and here's reality.
Shit, to the vise. Shit. Okay, it's in. Why does it always have to drop on the floor?
The other one was the same, minus the dropping. I learned.
To device. And now heat sink it.
While that's cooling, I could turn the shaft, which only needed its end turned down to fit the hand wheel, but also some threads that are very simple.
Please not broken, please not broken, please not broken. Yes!
And a 4mm keyway slot. Now the bearing part goes back in to finish turn the bushings.
Oh yeah, perfect fit. Nice. That's got to be the best slip fit I've ever pulled off. Only 2 to 3 micrometers of play. And then it's for a freaking unimportant hand wheel. Oh well.
Speaking of the hand wheel, I wanted to weld and turn my own, utilizing the laser some more, but there are also inexpensive, off-the-shelf cast iron hand wheels, much nicer than what I could make.
I've got this and more off-the-shelf parts for this project from Gantt & Norm, a great store for, well, off-the-shelf and standardized parts. Definitely check them out for your own projects. I've provided you a link for their European and US store in the description. This now fits and mounts to the upper tube here. No! I sized this hole to clear the gear and later when added the stopping collar forgot to adjust its size. Oh, come on.
Hole saw for the rescue.
So far so good, everything seems to work, and to later get the gear meshing right, there's quite a bit of movement in the mounting holes. So now the last part missing for this mechanism is of course the trapezoidal nut. It needs to be centered inside the bottom tube at about this height, so it will be welded to this piece of tubing and this then welded to the bottom plate.
The alignment of these parts is critical to prevent any sort of binding, so I turned both the inside of the tubing as well as the outside of the nut, and that makes sure everything is aligned. Ready for welding, this time with the 4mm setting.
That one is amazing.
I also turned this tubing to length to ensure it sits perpendicular on the plate.
Alright, got everything ready and prepared for welding, including these thinner plates that will help me with alignment, but you'll see. First thing is this tube on this plate.
I raised the plate from the table, slid on the first alignment plate on the tube, and positioned right, planted in place. Double checking it's square and tacking in 4 places with the 3mm settings. Looking good, so then the beads in between.
Beautiful little welds. But with a 3mm penetration into the material, this welding joint is essentially as strong as the tubing itself. Now I place some small nuts as spacers, bring this plate down, make it square and weld it on. This is now a guide for the bottom tube, which ensures the inner tube ends up centered. And then there's a second plate coming from the top. And so the inner tube now has a guide on top and bottom. So if there was any misalignment or there's weld distortion happening now, it will distort together and the two pieces will remain centered to each other, which is what counts here. For now, just those 4 tacks.
The first weld on the upper tube is a nut for the locking handle, which I could actually make from one of the laser cutting test pieces. I just needed to prepare the cutout section a bit more. After welding it in, I brought it back to the drill press to drill and tap the hole through the tube. And it still fits, but now with a locking handle.
To now align the top post with the top plate, I made another one of these thin alignment plates that fit the center hole with the shaft, post on top, and squaring it up. Unfortunately, checking square in this direction shows that I'm a bit more off than I want to.
But a quick touch with the grinder fixes that, and then it also got tagged together.
The shaft and alignment plate need to come out again. It looks like this just releases. Perfect. Let's test it. I first screw in the screw almost all the way. And when I put the top post on, the holes should line up. Oh yeah. Looks and feels good. Now let's try the hand wheel. What the? Nah, just kidding this time. Just need to crank it above the bottom post. Well, and there it works. Awesome. There's still a little bit of a noise when cranking down. But it could get better once there's grease and more weight on top.
Everything working means I can weld it solid.
Amazing. So clean. I didn't wire wheel it or do anything. This is straight after welding.
By the way, this little clamp you can see here is no ground clamp, but a safety loop circuit. So the welder will only emit a laser when you contact your workpiece.
Fascinating. The easiest part so far was the welding. But, of course, there's still weld distortion, and not too little.
But when heat from one side causes distortion, heat from the other side will fix it. So I scored the tube perimeter on the other side and ran beads with the same settings.
It's been just about a minute since I was welding, and I can already see and tell that it's working. But of course, why wouldn't it?
Same for the other piece, and then cooled down again.
I mean, come on, yes! Now just grind it flush and move to the next part of this project.
And that is the three-legged foot.
It's gonna be made from 50mm box section, again 5mm wall tubing, not for strength, that's way overkill, but for weight, because the further down the center of mass, the better.
Due to the shape, all 6 pieces have some sort of an angle on them, and I can highly recommend getting a cheap little metal chop saw with a good blade for such cuts. Super fast, super clean, and super accurate. While most cuts are at 60 degrees, where the 3 meet in the middle, it's a bit different. So I first cut those pieces to length square, then mark the angles on them that will meet in a point, and could use these scratch marks to align the saw blade. Then it's just more chop, 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 chop.
Fantastic! Couldn't be happier with that fit. Next, the parts get holes at specific locations, which is much easier to do while the parts are still separate and not welded. Let's double check those locations with the bottom plate. Yeah, the marks look centered in every hole.
I then started the hole with a step drill, which makes a really accurate guide for the normal drill bit to drill all the way through. And then I came back with a bigger step drill to open up the upper hole and fit some tubing that I'm gonna weld in. So later, when I mount the column and squeeze the juice out of the bolts, the tubing cannot collapse.
With 5mm wall tubing, probably unnecessary, but it just felt like the right thing to do.
Let's also check if the holes align when assembled.
Good, good, good. Now the leg pieces can go together, and to help me with the angle, you've seen them already, I've picked up some fireball tool tools. This one has the designed angle, it's just a bit short here, so I modified the hardware that came with it to make it longer with the second one. That should be a good reference. Now for tacking, the machine also has a tacking feature.
And that outputs short bursts of the laser without wire.
Super tiny tack, wonderful for thin material, but probably not so much here.
A very short weld like I did before is better suited, especially if there are also little gaps. Then for welding it out, I started with the outer corner, then the 2 sides welding away from the fillet, and lastly the fillet unclamped from the angle. I could also get more practice following the gun around the corner.
Result again looks really good, and applying what I've learned from the big tube, I managed to make this seam basically flush with the material. And angle-wise, this gap looks pretty even to me. Checking with a pin, making it flush here, it should just slide in here as well. Little bit of play, so not 100%, but I think good enough.
Then the other two. I really like this view. Right at the end, when I lose contact with the wire, the laser stops automatically.
Checking the other welds with this pin method, they are also not perfect, but they're all the same not perfect. And lining them up together next to each other like this, and their ends being this close to each other, I'm more than confident to say this is good enough. Also not forgetting there's no cleanup, no grinding necessary. Basically ready for paint. It's still fascinating. Next, in preparation for the retractable wheels, there needs to be a hole in a specific location, positioned relative to these two holes, which is why I'm doing it now, after the welding and little distortion already happened.
I ground the outer corner flush to put and accurately measure from, and using a bolt and angle as guides to mark the other dimension.
The fact that the marking ended up pretty much centered within the tube is a very good sign.
Like before, I used a step drill and smaller bit for a good guide through the bottom wall, and then opened up to 10 millimeters. With my welding table in the middle of the shop to work around it, I placed the parts and clamped them down.
In between here I should measure 100 degrees. Close enough. And 130 on the other two. Yes. And yes. So this is ready for welding.
Then I started with welding out the faces, and then the fillets.
There it's welded up, my three-legged thing. And I could also notice a problem with the laser welding, which is gaps. Right here, for example, was a little bit of a gap, and this isn't good. Let's do one more pass over it. Definitely better now. But it does make sense, since the welding concept is more focused on melting the base material together and adding just a little bit of filler. The wire feed is slow, so there isn't really new material to fill a gap with. It's definitely also a good amount of playing with the settings and practice, but I'm not sure if gaps bigger than 1 millimeter are possible with this system. Then you would need just more wire feed and more power. You know, let's test it. This is a 1 millimeter gap.
I had some starting difficulties, but adjusting some settings, and then
would you look at that? Not bad, but you could see what I was doing, kind of push into the weld paddle, let the gun feed a bit, push into the weld paddle, feed, push, feed, push, feed. And the result looks kind of like a super clean TIG weld now. And it's almost flush to the surface. I also had the scan width setting changed from 2 to 3 millimeters, which is how much the laser oscillates left to right. Okay. Seeing this route, I would change my mind and say bigger gaps are possible, but it's definitely a skill to practice.
Back to the base. It's almost complete.
On the bench again, the contact area and angles looks really good. The height is the same everywhere. Really happy with the result. So next I laser cut some more 6mm plates. Then I'm gonna weld on as feet. That's the legs complete, and while they're cooling, we can jump to the final part of this project I've been looking for all this time, the retracting wheels.
Conceptually, it's simple. 3 wheels live underneath the base, and when needed, lift everything up simultaneously. This is my final design, which actually doesn't need many parts. It's some box section that I already cut together with the other base pieces. Where the wheels attach, I again drilled holes with the step drill to weld in some tubing. Here it also makes more sense, since it's only 3mm wall thickness.
Next come the hinges with which the wheels are hinged and mounted under the base.
Obviously by now, some more laser cut parts. Once cleaned, I open up the holes to 10mm as well for the bolt.
They now go on the side with a specific distance to the end, and to help me with the alignment of the holes to each other, I turned this bushing from some tubing to the width of the box section. This keeps the alignment and distance, and this little offcut of round bar happens to be the right diameter for the correct spacing.
Next, of course, tacking and welding it on. Very little play.
Now with the wheel, when it's horizontal, it's up. And then with the other two wheels, and making them horizontal as well, it's fully up. Great. That works, so now the mechanism. It has to work like a pen. I want to press on the foot pedal into a stop, let go, then it's up, and press again into a stop, let go, and it's down. So, a pen mechanism on steroids to handle the weight.
I've built a mechanism like this for my hidden bed drawers already, but that mechanism has moving parts and I would like to eliminate that here. I found some inspiration from a retractable armrest mechanism. It's only got one rotating part and a special shaped housing. So I adapted this idea into my design and came up with this shape. The theory works, let's see if reality agrees. Obviously, the application for a laser cutter, and with the 3mm thickness, spectacular to watch. I've also got those settings pretty much dialed in, as you can see from the parts just dropping down.
I already did some parameter optimization, but these 3mm parts cut super clean.
The hole in the small piece I drilled and reamed to 6mm so I could
Simulate the movement. Seems to work. The plate goes here and the, let's call it clicker, here with a specific distance to the hinge.
So I got that laid out, drilled and reamed as well.
Okay, will it work? Oh yeah! That is exactly what I wanted. Oh, nice.
That's my first "it worked on the first try" moment. Except it wasn't smooth every time, but it also only took one rounding to be a bit rounder to fix. And then it worked great. Also when doing it more aggressively or faster.
Now with the wheel, it's up. But what about the other two wheels?
Well, there I am going a very pragmatic way and weld on two rods where the other tube pushes against.
And there we go.
With round on flat, there's a gap to fill with weld, so I again tried to push more filler into the weld puddle. And I'd say the result looks excellent. Like a TIG weld with lots of penetration.
Beautiful.
Yeah, enough babysitting. It's a foot pedal.
Huh. Do you see this? The weight of this bar is enough to lift it up. But there's also no weight on top. Robin up, nice view. Robin down, too bad. So with the 40 kilo vise and 20 kilo column, it will work. Now it's mobile and ready to use wherever I need it.
So let's put it to use for the final touches. I want to cap all of the tubing with this rusty piece of flat bar, and for cleaning it, the laser has me covered as well. Either handheld or in the CNC cabinet. Here before and after. I then cut it into smaller pieces with the laser handheld, for which it this time just uses compressed air. The finer work then at the vise and welding it on. For this kind of work, the laser is exceptionally great. It's fast, the parts don't get too hot, and the tiny beads are ground flush quickly. Nice. Next, a foot pedal plate with a grippy texture, for which I scored some grooves that again guide the wire and fill them with the bead. This worked, but I went off track a few times and did better on the other side, which took care of the warping too. Bye bye first try, hello foot pedal. Now this is still a problem. Just the weight of the lever applies about 10 kilos of weight on the wheel and thus less on the foot, which isn't ideal for stability. So I wanted to keep it up with a spring when not in use. That requires some hooks, which was a cool bending setup, and the laser could then just weld on that welding wire. It worked great, so I did the same for the other two wheels, which then had a cool side effect. The wheels now always rotate to the best possible position for lifting up the next time. A small but unexpected bonus. Then a 3D printed cap to protect the mechanism from debris, and on topic of 3D printing, I gave the feet some shoes from solid TPU and a wiper seal for the column, which is now also working smoothly. All that basically took was grease.
Who would have thought? Now, how about some paint? Awesome. So what could finish this project? My logo engraved into some brass, which is yet another feature of the laser system. Brass isn't officially supported, and this took 10 passes. Comes out much better on stainless steel, but still a usable result. It's great to finally have a functional vise in the shop that's truly mobile. But there is a problem. Although it is heavy enough to be stable for most of the work I do, you can't tip it. So what I probably end up doing is weld a piece of flat bar to the front here, so I can stand on it, and then it's stable. My conclusion about the laser system? Fantastic machine. It just performed at every task on this project. I didn't have a single problem, and I've actually already used it a lot more off camera, and second channel project coming. What a game changer. I know it's a huge investment, but the amount of capability and possibilities it opens up with this footprint is unmatched. So if you're interested, use my affiliate link in the description. It's an excellent support for my channel. Thank you, and see you next time. Just one more time. So good.